Alright guys, so you've had about 10 or 15 minutes to think about these questions as we're reviewing Trig today. First two, everybody should have got. If we're talking in degrees, what is one rotation? It's a 360, right? And if we do that twice, what is that? 720. And lastly, 1080. Alright, that was rotations in degrees, okay? Now, just as a review, when we're rotating, what is a positive versus what is negative?
Positive is counterclockwise.
Counterclockwise is positive, and negative is clockwise. Okay, so that's good to keep in mind. Okay, how many radians are in one rotation? If you look at your unit circle, it already has it filled in. It says one rotation is 360 in degrees. What's one rotation in radians? 2 pi. So then what is 2 rotations? And what is 3 rotations? Okay, now, this wasn't one of the questions, but it's going to help us on the next one. What is half a rotation in degrees? 180. So that's in degrees. But what's half a rotation in radians? It's just pi. Now, this is the same thing. 180 degrees is the same as pi radians. It's half a rotation. So this is actually what we're going to use in number 3 and 4. So number 3 says, how do you convert from degrees to radians? Who knows that one?
Pi over 1.
Good job. So, by the way, you only get 1.
Oh.
So, unless no one else can answer. So, this is going to be, I'm going to multiply by pi over 180. So, I'll put a times. So, you times by pi over 180. So, for example, if I said, hey, what is 45 degrees in radians? I'm going to times it by pi over 180. Now, on your calculator, to make life easy, get out your calculator. Everyone's got the yellow calculator, right? Just don't worry about the pi, just do the 45 over 180. So go on your calculator, put in 45 divided by 180 and push enter.
That's 0.2 times.
And it's going to give you a fraction, or a decimal. How do you change that decimal into a fraction? Thanks, Nazram. Math enter, enter. So 45 over 180, what does it reduce to? 1/4. Now we still got that pi, so I'm going to write that as pi 4th. So that's how you change something from degrees to radians. And if you look on your unit circle, does 45 degrees and pi 4ths line up at the same spot? Yes, okay, great. So now someone besides Caleb, let's do the opposite. How do you convert from radians to degrees, Noah? There we go. We're going to do 180, so just flip it. It's actually what I have right here. So I'm going to times by 180 over pi. For example, if I had, let's just say, 2 pi thirds. That's in radians, and I want to change that into degrees. I'm going to times it by 180 over pi. And now I'm going to have a pi in the numerator and a pi in the denominator. Pi divided by pi is 1, so the pi's go away. Then I'm just going to say 2 times 180 is 360, and 360 divided by 3 is 120, I believe. Will you guys look on your unit circle? Is 120 degrees in the same spot that 2 pi thirds is? Boom, shakalaka. We got it, right? Okay, so there you go. That's how you convert from degrees to radians. That's going to be on your test as well. Now, let's switch over to the word coterminal. Who can tell me what the word coterminal is and give me an example? Go ahead, Elsie. Yes. Can you give me an example? All right. Catch. Good job. So they have the same terminal, which is where it ends. So they land on the same spot, okay? I'm going to write this down. So this is going to be angles that land in the same position. And I asked Elsie to come up with an And what did you say, what was the angle that you chose? Okay, so 230 is going to be, it goes past 90, past 180, and it goes past 180 by 50 degrees, right? So it'd be about right here. This would be the angle, let's draw like this. So this angle right here is 230 degrees. But I could also get to this angle by going clockwise. I'm going to go back 90, and then I'm going to go 40 more, so that's negative 130. You see how they land in the same spot? That means they're coterminal. Okay? So coterminal, they land in the same spot. So then let's go to number 6. How do you find a coterminal angle when given an angle? For example, what is a positive and negative coterminal angle of 30 degrees? Who wants this one? Go ahead, Jordan.
So to find it, we just have to do 30 plus 360.
Mm-hmm. So 30 plus 360 is 390. 30 minus 360 is negative 330. Okay, let's check that out. So if I were to graph 30 degrees, which quadrant is that in? Here's 30 degrees. Now, if I were to then do 390, I'm going to go around 360 and then do 30, and look, it lands at the same spot. So are they coterminal? Yes, sir, they are. What about negative 330? Well, if it's negative, now I'm going to go clockwise, but I don't go all the way around. I only go 330, which is 30 degrees short of a rotation. It lands in the same spot. So adding and subtracting on rotation, full rotations will give you coterminal angles. Boom! That is quiz 1. Good review? Okay. Let's go to 7 and 8. How do you find the sign of angles on the unit circle? So if you flip your paper over, we've got the unit circle all filled out for you, right? Now, if I said, hey, what's the sign of 30 degrees, or what's the sign of 2 pi thirds? How do you figure it out? What are you looking at? Go ahead, Khadija.
You'd look for an angle. You'd look for the y coordinate of it.
Boom, good job. So the sign is going to be the y coordinate on the unit circle. So for example, if you had a question that said, what is the sine of 150 degrees? Let's do that together. Look at your unit circle and go find where 150 degrees is. Now, when you look at 150, it's going to have 2 coordinates, right? What are the coordinates at 150? Give me the x one first. Is it negative square root of 3? And what's the y coordinate? So then, if we're doing sine, which one of those do we want? The y, which is right there. That's how you can do it. And you can check your work on your calculator. Just make sure you're in degrees, okay? Okay, so that's how you do sine. Did I give you one? Did I toss one to you?
No.
You want one? Who wants to take cosine? Go ahead, Nazaro. Yeah, so I'm just going to look at the x coordinate. So let's do a different example. If I said, hey, I want you to do the cosine of 7 pi fourths. So I'm going to stay with Nazaro on this one. Nazaro on 7 pi fourths. What are the coordinates, the x and the y? So these are the coordinates at 7 pi fourths. And if we're doing cosine, which one do we want? Awesome. Is that a question or are you just scratching your head? Oh, you did. He's like, hey, pay up. Okay, that's how you do sine, cosine. Now, what about tangent? Tangent was a little tricky. Do you remember how we got that one, Jordan? Awesome. Or if we saw from here, y over x. So good job. So let's do that one together. So to do the tangent of theta is, I could think of it as sine over cosine, which that's going to come into play when we talk about trig identities. Or you could think of it as y over x. So let's do an example together. Let's say I wanted you to figure out the tangent of, what's one we do? Let's do 3 pi fourths. Okay, Brian, I'm going to have you help me on this one. Will you look on your unit circle? It's on the back. What are the coordinates? Find where 3 pi fourths is. And then what are the coordinates at 3 pi fourths? Negative square root of 2 over 2, okay? And is it a negative as well or positive? Okay, cool. Okay, now this is my x, which is cosine. This is my y, which is sine. But if I want to do tangent, what am I going to do with those? You're going to divide those. So I'm going to take those, and I'm going to take the square root of 2 over 2 divided by a negative square root of 2 over 2. And what do you notice here? Sometimes when we were doing this, we said, oh, I'm going to have to keep, change, flip, and then simplify and all that stuff. What are we dividing here? It's the same thing. What happens when you divide something by itself? What does it turn into? 1, except it's not exactly the same. What's still left over? Good job. So this, I'm going to just cross out the square root of 2 over 2. This just turns into negative 1. So the tangent of negative 3 pi fourths is negative 1. So you're dividing the y by the x. We're all remembering that? Awesome. We're so close, guys. You're doing great. Let's now switch gears here. I think we're on the last one. When given an equation such as cosine of theta is 1/2, how do we find theta? Someone who hasn't gone yet? Go ahead, Sitlali. Good, so we could take the inverse cosine of each side. So I'm going to go through and say, all right, I'm going to take the inverse cosine of the cosine of theta. These guys cancel each other out. However, if I take the inverse cosine of one side, I've got to do it at the other side. So then, now here's my question. How do we use our unit circle to figure that out? Get out your unit circle, guys. And if we're talking about cosine, which letter are we talking about, x or y? X. I want you to look on your unit circle at your x values, and I want you to see where is the x value 1/2. So it's at 60 degrees, and where else? 300 degrees. So the answer, you're going to have two answers here. Theta could be 60 degrees, or it could be 300 degrees is what we said, right? Because at both of those, the x value is 1/2. Now, if you wanted, you could plug it into your calculator, but your calculator just gives you one of those options. Also, I should have put this as a question. What do you always check before you go on your before you put anything in your calculator? Degrees and radians, right? Because if I put in something like this and it's in radians, then it's going to give me a weird answer. So you got to make sure you're in the right mode. And there might be times you want to be in radians and you might want to be in degrees. For the most part, we'll probably be in degrees. Question, Jordan? Yeah, so if you look on your calculator above cosine, do you see where cosine, above it in blue it says cosine is a negative 1. You push that and put in 1/2. Yeah, so when we do plain old cosine of an angle, then I'm saying, hey, find that angle and find the cosine, which means you're doing the adjacent over the hypotenuse, because cosine is adjacent over hypotenuse. On the unit circle, it's the x value. when you're doing the inverse cosine, then that's where you're saying, hey, I'm not trying to figure out the adjacent and the hypotenuse. I'm trying to figure out which angle would give me a certain ratio of adjacent over hypotenuse. So this one, it helps you find a ratio. This one, it helps you find an angle. So this is going to be this. We use inverse cosine to find angles, and this one, it gives us a ratio of the adjacent over hypotenuse. Does that make more sense? Kind of opposites of each other. Okay, now you've done that. This is kind of your study guide to help you figure out your review. Will you also get out, do you have your law of sines one that we did a couple of times ago? Can I borrow yours, Jordan? Or wait, no. Someone have it out. Somebody have your law of sines one? Yes, thank you. No, I'm going to borrow yours. Will you guys get this out too? So what I want you to do is you are going to now use the study guide you just filled out and the law of sines, law of cosines, and you are going to go through this review packet. Now, if you picked up this packet and you're like, holy cow, this is like a book. Well, it's because I included the key in it, but the key, it didn't do like an answer sheet. It did it, it just printed them like, it reprinted it but added the answers. Does that make sense? So there's 36 questions, and then it's got the answers. And some of them it doesn't have the answers, but most of them it does, okay? So you're going to work with your buddy and try to get as far as you can on this. And what I would recommend is doing the problems, like working with your buddy on the questions that are the hardest for you to do. Because then you can get help from your buddy, or you can get help from me. And save the ones that you know how to do for when you get home. Sound good? All right, so then we're going to use rest of time here, get working on this review.